Use Wireshark to examine Ethernet frames topology. Use the connection to Internet through a router, and when upper layer protocols communicate with each other, data flows down the Open System Interconnection OSI layer and is encapsulated into a layer 2 frame. The frame composition is dependent of the media access type. For example, if the upper layer protocols are TCP and IP, and the media access is Ethernet, then the layer 2 frame encapsulation will be Ethernet 2. This is typical for LAN environment. Required resources: one PC with Windows and Internet access, Wireshark installed. Examine the header fields in an Ethernet 2 frame. You will examine the header fields and content in an Ethernet 2 frame. Review the Ethernet 2 header field descriptions and lengths. Preamble 8 bytes, destination address 6 bytes, source address 6 bytes. Okay, 6 bytes for the MAC address, 48 bits equal to 6 bytes. Frame type 2 bytes. Data 46 to 1500 bytes, and frame check sequence 4 bytes. Examine the network configuration of the PC with ipconfig all. Okay, use an Ethernet adapter. So you need a connection to your Ethernet adapter using a copper cable connected to a switch. Command prompt ipconfig all. This is my Ethernet adapter. My IP address, in my case, 192.168.170, subnet mask 255.255.255.0, default gateway 192.168.1.1. DNS servers. Examine Ethernet frames in a Wireshark capsule. The screenshot of the Wireshark capture below shows the packets generated by a ping being issued from a PC host to its default gateway. Remember, if this is my local PC 1.70, ping to the default gateway 1.1. 192.168.1.1. Okay, ping again. Success. Okay, but capture this. Okay, open Wireshark. Be sure the Ethernet interface has traffic. Okay, this is the traffic, very good. Double click here to start the capture. And repeat the ping. success. And finally, stop the capture with the red square button, and look at this. A filter has been applied to Wireshark to be the ARP and ICMP protocols only. And here ARP or ICMP. Enter or simply click here to this arrow and ready. ARP stands for Address Resolution Protocol. ARP is a communication protocol that is used for determining the MAC address that is associated with the IP address. The session begins with an ARP query and reply for the MAC address of the default router, followed by 4 ping requests and replies. Okay, this is the example. Okay, on yellow, ARP requests and on pink, ICMP. This screenshot highlights the frame details for an ARP request, and this screenshot highlights the frame details for an ARP reply. Examine the Ethernet2 header contents of an ARP request. The following table takes the first frame in the Wireshark capture and displays the data in the Ethernet2 header fields. Okay, remember, these are the Ethernet fields: preamble, destination address, source address, frame type, data, frame, check sequence. And the value, finally, the description. For example, preamble not shown in capture. This field contains synchronizing bits processed by the network interface card hardware. So it's not shown on Wireshark. For example, select this ARP. Okay, look at I don't have an ARP from my PC to the default gateway. For example, this is the question: who has 192.168.1.220 till 192.168.1.70? This is the source, my local IP address, remember, 170. The question should be who has 192.168.1.1. And tell 192.168.1.70. So I don't have 1.1. Okay, but don't worry if you don't have the IP address of your default gateway listed here. I will use this, the first, for example, who has 192.168.1.220, tell 192.168.1.70. So my local PC is asking who has the IP address 192.168.170. Okay, select the first or any similar and go to middle section here and look at this. There is no preamble, so it's not present on Wireshark. Now, verify the destination address should be a broadcast. Okay, go to Ethernet 2 on the middle section. Remember, I have selected the first in my case, or select any of these ARP requests, Ethernet 2, and this is the source, this MAC address, and the destination is this FFFF. Or you can expand this and look at this. The destination is a broadcast MAC address. Okay, FFF, that represents ones in binary, but an hexadecimal is FFF. Okay, and so it's a broadcast. The source should be the MAC address of my local PC. Okay, the source is this 54AB3A5B AD04, 54AB3A5B AD04, very good. Layer 2 addresses for the frame. Each address is 48 bits long or 6 octets expressed as 12 hexadecimal digits from 0 to 9 and from A to F. A common format is this. The first 6 hexadecimal numbers indicate the manufacturer or the network interface card. Okay, this. So that's why it's expressed with the manufacturer. In this case, net year. Okay. The first 6 hexadecimal bits, in my case, are represented by Quanta Corporation. The last 6 hexadecimal numbers are the serial number of the network interface card. Okay, this is the serial number. In my case, is this 5B8004. The destination may be a broadcast, which contains all ones or a unicast. The source address is always unicast. Okay, destination can be a unicast or broadcast. In this case, a broadcast, and the source is always a unicast. Now, frame type. 0x means that this is an hexadecimal number, 0806 hexadecimal. This is ARP type for the frame hexadecimal 0806. This field contains the hexadecimal value that is used to indicate the type of upper layer protocol in the data field. There are numerous upper layer protocols supported by Ethernet 2. Two common frame types are these: 0800 for IPv4 protocol and 0806 address resolution protocol. In this case, for ARP. Data ARP contains the encapsulated upper level protocol. The data field is between 46 and 1500 bytes. Okay, so This is the data address resolution protocol. You can expand this, and this is the content of the data. Okay, it's an ARP request for IPv4. The source MAC address, the source IP address, the destination MAC address is not specified because you are asking what is this MAC address, but so you don't know what is and the source IP address. Frame check sequence not shown in capture. Frame check sequence used by the network interface card to identify errors during transmission. The value is computed by sending device encompassing frame addresses, type, and data field. It is verified by the receiver. Okay, frame check sequence not in the capture. What is significant about the contents of the destination address field? All hosts on LAN will receive the broadcast frame. The host with the IP address of 192.168, the host with the destination IP address that can be 192.168.1.220 or 192.168.1.1, the default gateway, will send a unicast replay of the source PC host. This replay contains the MAC address of the network interface card of the default gateway, or contains the MAC address of the network interface card of the destination IP address. Why does the PC send out a broadcast ARP prior to sending the first ping request? A PC cannot send a ping request to a host until it determines the destination MAC address, so that it can build the frame header for a ping request. The ARP broadcast is used to request the MAC address of the host with the IP address contained in the ARP. What is the MAC address of the source in the first frame? In my case, is this 54AB3A5B8004. What is the vendor ID OUI of the source NIC in the ARP replay? Okay, I don't have here a replay, only requests for ARP. All are requests, all requests. But in my case, the source in my case is Quanta Corporation and may vary. What portion of the MAC address is OUI? First 3 octets of the MAC address indicate OUI, or 24 bits, or the first 6 hexadecimal numbers. What is the network interface card serial number for the source? Okay, this is the last 6 bits for the source, 5B8004. may vary. Use Wireshark to capture and analyze Ethernet frames. Determine the IP address of the default gateway of your PC. What is the IP address of the PC default gateway? May vary. In my case, is this 192.168.1.1. Start capturing traffic on your PC NIC. Open Wireshark to start data capture. Observe the traffic that appears in the packet list window. Okay, this is the packet list window, the top section. Okay, you can do a new capture if you want, or maybe you can use this capture, but to practice I will create another capture. Only press to this button, the blue button, start capturing packets, continue without saving, and ping the default gateway, ping 192.168.1.1 in my case. Okay, stop the capture with the red square, filter Wireshark to display only ICMP traffic. Okay, here only ICMP. Press enter or apply using this button, the arrow button, and ready. Only pings, only ICMP. Examine the first echo ping request in Wireshark. The Wireshark main window is divided into three sections. The packet list pane top, okay, packet list pane top, packet details pane middle, here packet details pane the middle, and packet bytes pane bottom, and packet bytes pane bottom. In the packet list pane, click the first frame listed. Okay, the first here. You should see echo ping request under the info heading. Okay, on info request, echo ping request. Examine first line and the packet details pane, the middle section. The line displays the length of the frame. Okay, here the frame 74 bytes. Okay, that is the same of 592 bits. The second line in the packet details pane shows that is Ethernet 2 frame. Source and destination MAC addresses are also displayed. Okay, the second is this Ethernet 2, source MAC and destination MAC. What is the MAC address of the PC NIC? Is this 54AB3A5B8004? May vary in your case. Okay, this. The default gateway MAC address is this. Okay, the manufacturer, in this case, ICMP, and is this the MAC address of the default gateway. You can click the greater than sign at the beginning of the second line to obtain more information about the Ethernet to frame. What type of frame is displayed? Okay, expand this, and the type is this, IPv4, and hexadecimal is 0800. The last two lines displayed in the middle section provide information about the data field of the frame. Notice that the data contains the source and destination IPv4 address information. What is the source IP address and destination IP address? Okay, click here. The source IP 192.168.170, my local PC, and 192.168.1.1, the default gateway. Click Internet Control Message Protocol line in the middle section and examine that is highlighted in the packet bytes pane. Click to Internet Control Message Protocol, and you can see on the bottom pane and the packet bytes pane is highlighted here. What do the last two highlighted octets spell? High. Okay. You can click any line in the middle section to highlight that part of the frame. Hexadecimal and ASCII in the packet bytes pane, bottom section. Okay, this is the hexadecimal on the left, and on the right ASCII. Click the next frame in the top section and examine an echo replay frame. Okay, the next on the list pane and top, and it's a replay. The source now is the default gateway, and the destination now is the local PC. What device and MAC addresses? What device and MAC address is displayed as the destination address? Okay, go to middle section, the details, and this is the destination, my local PC, 54AB3A5B8004. Okay, start a new capture to capture packets for a remote host. Okay, go to blue button, continue without saving. The filter is still applied, don't worry, and ping to www.cisco.com. Okay, again, ready. Look at this. Okay, stop the capture with the red button. Examine the new data in the bucket list pane of Wireshark. In the first echo ping request frame, what are the source and destination MAC addresses? Okay, select the first here and go to details pane, the middle section, expand Ethernet to This is the source, my MAC address, the MAC address of my local PC 54AB3A5B8004, 54AB3A5B8004, and this is the MAC address of the default gateway. B0, B2, AF, C2, 74BB. How you can verify this? Only you can do this. ARP option A, dash A, okay? And this is the ARP table. So my default gateway has the MAC address B0, B2, AF, C2, 74BB, and it's this. Okay, so the destination for the ping to cisco.com, the destination MAC address is B0, B2, AF, C2, 74BB. Okay, but remember, the source IP is 192.168.170. My local PC and destination IP is 23.202.91.188. In my case, may vary. Okay, this IP, the destination IP that is resolved by the DNS. Okay, and what are the source and destination IP addresses? Okay, expand this, Internet Protocol version 4, source IP, my local PC, destination IP, cisco.com, but this is the IP address of cisco.com in my case. Compare these addresses to the addresses you received in step 6. The only address that changed is the destination IP address. Why has the destination IP address changed while the destination MAC addresses remained the same? Layer 2 frames never leave the LAN. When a ping is issued to a remote host, the source will use the default gateway MAC address for the frame destination. The default gateway receives the packet, strips the layer 2 frame information from the packet, and then creates a new frame header with the MAC address of the next hop. This process continues from router to router until the packet reaches its destination IP address. Wireshark does not display the preamble field of a frame header. What does the preamble contain? The preamble field contains 7 octets of alternated 1010 sequences and 1 octet that signals the beginning of the frame, 10101011. 1, 2, 3, 4, 5, 6, 7 octets of alternated 1010 sequences and 1 octet that signals the beginning of the frame 10101011.